All right, let's jump right into this explainer and unlock the real power of automation using Linux Cron Jobs. Look, if you're starting your journey into DevOps, you're going to quickly realize that automation is basically the beating heart of the discipline. We absolutely want machines doing the repetitive, boring work so we can focus on the bigger picture. So, picture this scenario. You've got this crucial shell script sitting on your server. It's designed to generate a resource usage report every single day at exactly 6 p.m. But, well, what happens if you have an emergency? Or what if you simply forget to log in? Imagine the sheer panic of missing a crucial deadline, or worse, costing your company money just because of human error. It's a classic DevOps nightmare, right? To fix this, we're going to break this explainer down into 5 super manageable sections. First, the DevOps automation problem. Second, enter the cron job. Third, cracking the cron syntax. Fourth, managing the cron service. And finally, some real-world cron examples.
Okay, Section 1. The DevOps automation problem, or as I like to call it, the pain of manual toil.
Think about it. Needing to manually log in and run a script every single day at a specific time? It's tedious. And honestly, it's highly error-prone if you happen to be unavailable. Whether you're generating reports, backing up a database, or clearing out temp files, relying on a human to press enter at the exact right moment is just a massive risk. Humans get sick, we take vacations, and yeah, we forget stuff.
And this quote right here brilliantly illustrates the exact problem with manually managing things, especially cloud infrastructure like AWS EC2 instances. If you spin up a server to run a script and you forget to tear it down when the work is done, well, that server just sits there eating up your cloud budget. You are literally paying for forgetting. Ouch.
Moving on to Section 2. Enter the cron job, your ultimate silent assistant. So, how do we actually eliminate this manual toil? We need a way to tell our Linux machines to handle the scheduling for us. Think of a cron job as your incredibly reliable silent assistant. You just tell it when to act, and it waits in the background to perfectly execute your script. Fun fact, the name actually comes from Chronos, the Greek word for time. It's a time-based job scheduler built right into Unix-like operating systems.
When we compare these workflows side by side, it's pretty obvious that cron execution is vastly superior for any DevOps engineer looking to optimize their time. With manual execution, the point of failure is, well, you. With cron execution, you write the script once, you schedule it by simply typing crontab-e in your terminal to open your schedule file, and bam! The operating system guarantees 0 missed deadlines.
All right, Section 3. Cracking the cron syntax, also known as the magic spell.
Now, if you've never actually seen a cron expression before, it can look pretty intimidating, just a confusing row of asterisks and numbers. But I promise you, it's incredibly logical. The crucial takeaway here is that every single cron expression is built using 5 specific time parameters, always in this exact order: minute, hour, day of the month, and day of the week. And if you see an asterisk in any of these spots, it simply means every. So an asterisk in that first column means every minute. If you wanted a script to run at 6:30 a.m., you just drop a 30 in the minute column and a 6 in the hour column. Easy, right?
Setting this whole thing up is just a simple 3-step process to ensure your shell script fires off exactly when needed, say every Monday morning. You just figure out your time, translate it into those 5 columns, and then add the full absolute path to your script right at the very end of the line. And hey, later on, you can always just type crontab-L to list out and verify all your scheduled jobs.
Let's hit Section 4, Managing the cron service, or controlling the engine.
So how does Linux actually know to read your crontab file and execute those commands? Well, because cron is a system service, it operates in the background, and that means it comes back up automatically even if your entire virtual machine has to be rebooted. It runs constantly in the background as a daemon process, which is usually called croned. It literally wakes up every single minute, checks the crontab files, and sees if any scheduled jobs match the current system time. And as a Linux administrator, you have total control over this engine using systemctl commands. You can start it, view it, or temporarily stop the cron service altogether. As you probably know, systemctl is basically the master utility for managing services. So while you'd use the cronjab command to edit your personal schedule, you use systemctl to manage the cron engine itself. You can list running services to make sure cron is active, or safely stop it if you're doing some heavy system maintenance and absolutely don't want background scripts firing off unexpectedly.
Finally, Section 5, Real-World Cron Examples. Let's see this automation in action.
We've got the theory down, but what are professionals actually doing with this out in the field? Take use case 1. Instead of manually checking your AWS resource usage every single evening, a cron job can automatically generate and email the report precisely at 6 p.m. You might have a shell script that pulls data on active EC2 instances, S3 buckets, and IAM users. You literally just schedule that script in your cron tab, redirect the output to a file, and boom, you've got a perfect, automated, daily audit trail without lifting a single finger.
And this quote brilliantly highlights another huge use case, how cron triggers can be connected to AWS CloudWatch and Lambda to automatically tear down unused servers, which saves massive amounts of money. It's a perfect example of event-driven architecture. A cron expression in CloudWatch triggers a Lambda function, which runs your tasks and then immediately destroys the compute resources, meaning you never pay for an idle server overnight ever again.
Here's another incredibly common daily task, using a cron job to periodically zip and archive massive application logs. This stops your Linux disks from filling up and completely crashing. Applications write logs every second, right? If left alone, they will absolutely consume all your disk space. A simple cron job running a compression script every night at midnight ensures your active logs stay manageable while still preserving all that historical data for auditing. So, now that you hold the power of the ultimate silent assistant, I've got a question for you. What repetitive manual task are you going to automate first using your new crontab skills? The syntax is straightforward, the service is incredibly robust, and the real-world applications are literally endless. Start looking for those tedious, repetitive manual tasks in your daily workflows and just hand them over to Linux. Thanks for hanging out with me for this explainer.